All right. Believe it or not, this is the last set of notes that you have to do for PreCal seniors. Thank you for those of y'all that have participated every week, done the assignments, done the quizzes. It's been very nice to know that all of the work that I, Mr. Engel, have put into this online course, that you've taken advantage of it. I know some of this material is hard, but it's good to kind of challenge your mind in this weird time of ours. So what we're going to end with is doing everything that we've done with arithmetic, but doing it with geometric sequences. So we have formulas for geometric sequences that we are going to use here. So we want to start off here by first finding out an explicit formula for this sequence. Well, some of y'all, if you look at this, you should notice that we're adding 4 each time. So that means this is an arithmetic sequence. So we're going to go back to that formula of a sub n equals a sub 1 plus n minus 1 times d. In the real classroom, we would have had a review day practice test or review quiz with all of the sequences and series, and you had to know all the formulas, or we have them on the top of the front page of your test. But it would have included everything that we've done. Now, this is a little bit of review, that if I'm writing an explicit formula, I need to put in the first term, leave it in terms of n, and my common difference is 4. Again, make sure you fully simplify this. If you distribute the 4, then your final equation would be 4n minus 3. So that would be an explicit formula for an arithmetic sequence. Now, what we're going to introduce today is geometric sequences. So we have a brand new formula here, which almost looks exactly the same, but instead of it having a common difference, we have a common ratio. And since we're multiplying, we're going to have exponents involved here. So let's dive right in. Given this sequence for negative 1236, let's write an explicit formula. Well, a sub n equals the first term, which is 4. My common ratio, what am I multiplying by? Well, negative 3. And it's very important that you put that negative 3 in parentheses. Okay, so again, we're multiplying by negative 3. And then do n minus 1. Now, as much as some of y'all would love to multiply that to negative 12, that does not actually happen. You need to be following the order of operations. The order of operations says what to do, what's inside the parentheses, which there's nothing to do. Then you do the exponent, then you multiply. So make sure that you are not multiplying before the exponent. So there's literally nothing else you can do here. So if you're finding the 6th term in the sequence, you're going to plug in 6 for every n that you see. Now, you could simplify that a little bit, and in your head, you probably don't know what negative 3 to the 5th is. And multiplying that by 4 doesn't help any bit. But if you put that in the calculator, you end up getting negative 972. So if you were to continue the pattern of multiplying by negative 3, you would end up getting that negative 972 is your 6th term in that sequence. So what about this next question? Let's just write an equation for it. The first term is 6. Our common ratio, what am I multiplying by? 2. So in my equation, since it's geometric, it's just the first terms times the ratio to the n minus 1 power. Now, some of y'all might be asking, well, why do I have to put parentheses there? Do I have to? No, not in this case, but if you just always put the ratio in parentheses, you're going to make your life so much easier. If I ask you to type this out into a quiz, then if you don't put parentheses on it, you're going to get it wrong. So pay attention to those parentheses. It's important. So which term of the sequence is 1024 in this? So anytime we're asking for which term, we're looking for what does n equal. So let's write an equation. A sub n equals the first term. And is this arithmetic or geometric? Well, you should notice it's geometric. We're multiplying by 4. Okay, so that's my equation. That's as far as you can go. You cannot go any further, which honestly you might be able to, but we're not going to get into that. That is as far as I need you to go, is to leave it like that. So what I need to do is figure out what n is by setting this equation equal to 1024. So I'm going to do some math here. I'm going to multiply both sides by 4 to get rid of the 1/4 on this side. And when you do that, you get 4096. So what you're going to have to do is something that you did in Algebra 2 and get both of these to be the same base. Well, what's nice about this problem is 4096 is actually the same thing as 4 to the 6th power. So since we have both bases are the same, you can drop them and set their exponents equal to each other. So you find out that 1024 is the 7th term in that sequence. So again, this is stuff that we're using everything that you've learned in algebra and algebra 2 just to solve a problem. Okay. Write the first 5 terms of this. Well, guess what? I gave you the first term already. What you need to do is find the second, the third, the fourth, and the 5th term. So this is kind of going back to day 1. If I'm looking for a sub 2, I need to plug in a value of k here to make that 2. So that value of k would have to be 1 because this has to match up. These have to be equal. For k, for this subscript to be 2, k has to be 1. So that means for every k that I see, I plug in 1. Well, if it's 1/5 of a sub 1, do I know what a sub 1 is? Yeah, we told you it's 20. So what's 1/5 of 20? Well, that's 4. So can I find the 5th term here? Can I do that here? No, this is called a recursive formula. I need to know the previous term, just like how I needed to know the first term in order to get the second one. In order to find it. So we need to go in order. The third term. What am I plugging in k for? With 2. You have to plug in 2. Otherwise it won't equal. This subscript has to be the same as this subscript. And I got this subscript because I'm looking for the third term. So I'm doing 1/5 of the second term, which is 4. So the third term is 4/5. Some of y'all realize like, oh, well, you're just taking 1/5, you're dividing by 5. So you're going to get 4/25 and 4/125. But sometimes it's not that easy. So what you want to do is plug in 3 for every k that you see and get 1/5 of the previous term. To find the 5th term, you're plugging in k is 4. So you're taking 1/5 of the previous term. So again, some of these recursive formulas are a lot easier than others, but you need to understand the notation. You need to understand how to plug things in. All right, so let's write things in summation notation or sigma notation. So again, in this class, we should always have this. This should always be the same. If you notice from the previous quiz, that answer should have simply been 1. Again, in this class, we always leave this as 1. As 1. Now I need to figure out what my series is. Is this geometric or is it arithmetic? Well, you should notice that I'm adding -3 each time. So since I'm adding, I need to do arithmetic. So I need to have an equation. So this is the one where it's a sub 1, which in this case is 5, plus n minus 1 times my common difference. So I distribute the -3 and end up getting the equation is negative 3n plus 8. Again, 8 minus 3n also works. Then, again, some people might still be plugging in this last number. You're going to tell me that's 55 or negative 55. And that doesn't make sense. You cannot go 1, 2, 3, 4, 5, 6 all the way to negative 55. You cannot do that. You need to be able to plug in this top number to get the last term. So I need to set this equation equal to negative 55. So when you do that, you subtract the 8 on both sides and end up getting that n is 21. Now, is 21 anywhere in that series? No, but that is the number that you plug in to get the last term. That's what's very important. Now, what about this next one? Again, if we're asking you to write sigma notation, we're going to ask you to draw this and put n equals 1. That always happens. That's the same thing. Now, what's lucky about this one is that this never stops. This goes on forever. So that means I'm going to put an infinity symbol there. But how do I write an equation? Well, that's what we talked about today. If we're writing an explicit formula for this, we do the first term, which is 6, times the ratio. What am I multiplying by? Well, negative 2 to the n minus 1. You cannot simplify that any further. So that's it. So I try to give you this on a quiz, so make sure that you understand that when I'm doing this, I'm asking for those three things. The first term, the ratio, should be in parentheses, and the blank might not look like a exponent, but it's supposed to. It's supposed to look like a superscript. Now, for adding up geometric series, we actually have two different equations, and it's a little bit more intense than what we had for arithmetic. So this is my equation for the sum of a finite geometric series. That means I have a certain number of terms. So if I'm given this, I need to figure out what n is. And n doesn't just equal 1. N is the number of terms that I'm adding up. And in order to do that, we do the top minus the bottom plus 1, which is 8. Which makes sense because if you count 1, 2, 3, 4, 5, 6, 7, 8, that's 8 numbers. So you're plugging in 1, 2, 3, 4, 5, 6, 7, 8 and getting 8 different numbers. So I'm going to find the sum of the first 8 terms of this series. How do I figure out the first term? Well, we plug in the bottom. We plug in the bottom into my equation. So plug in 1 into n, and you get negative 3 to the 0. And this is where I ask you in class, what's negative 3 to the 0? And everybody says 0. And I'm like, nope, that's not right. Anything to the 0 power is 1. So a sub 1 is 1. 1 minus, what's my ratio? Well, I would be very careful and plug in the next number. Plug in 2 and get negative 3 to the 2 minus 1. So you get negative 3 to the 1, which is negative 3. You can keep going, find a third term, and get 9, and figure out that, yes, you are multiplying by negative 3. However, it is very important for you to put that in your parentheses. So, negative 3 is my ratio, because that's what I'm multiplying. You could assume that it's just the number that's being raised to the n minus 1, but be very careful. N, we found out that we're adding 8 terms, and then over 1 minus the ratio of negative 3. Hey, sweet. I don't have to solve for anything else. I just need to figure out what this is. Well, guess what? Well, hopefully you have one, but you can use a calculator. So, in this case, hopefully I don't get any alerts on my phone, but I'm going to use my calculator here. So, I'm going to put my fancy fraction, do 1 parentheses 1 minus negative 3 to the 8th power. Oops, probably shouldn't put that parenthesis in the exponent. There we go. And then 1 minus negative 3. And you end up getting an answer. of negative 1,640. Again, there's different, if you want to know how to get the calculator onto your Android phone, I can tell you there's another app for iPhones and iPads for you to get a TI-84 to do that in. Or, you just do it piece by piece instead of putting it all in the calculator. All right, the next one. Let's find out how many terms we have in this equation. So the way to figure out how many terms in this series is you do the top minus the bottom plus 1. So we end up getting that this has 6 terms. Think about it. If you plug in 0, 1, 2, 3, or 0, 1, 2, 3, 4, and 5, how many answers do you get? You get 6. So that is very important to understand of how to find out how many number of terms you have in it. It's the top minus the bottom, and you always add 1 to it. All right. Well, we need to figure out our first term. Well, we plug in our bottom number into the equation. Now, some of y'all might think, oh, the whole thing is taken to the 0 power, but it's actually only the 2/5. So 2/5 of the 0 is 1. So our first term is 10. Again, if you wanted to, you can plug in the next number in our sequence, which is going to be 1, which 10 to the 2/5, or 10 times 2/5 will end up being 4. And then so on and so forth. So you end up finding out that your ratio is 2/5, which is inside of that. Okay. All right. So I'm looking for the sum of 6 terms because, again, when I count 0, 1, 2, 3, 4, 5, and 6, or 5, I get 6 terms. My first term is 10, and my ratio is 2/5. And again, that's very important that you put that in parentheses. Now, I'm not going to bore you putting this into my calculator again, but to do that, you get 10,374 divided by 625. Again, there's nowhere in here that says to round. If you put this into the calculator, it gives you a nice terminating decimal, then yes, you can type that into your quiz. But just to be safe, always make sure that you are entering the most reduced fraction. All right. Then we have one more formula. What's crazy is that with geometric series, if I just add a whole bunch of numbers that have a pattern of being multiplied by something, it actually ends up converging to an answer. It actually ends up converging to a certain number. Like, for example, like halves. If I were taking half of something, then, that's a geometric series. So, like, for example, if I start off with the square of a half, that's my first term, and I added half of that, well, half of this half is a fourth of this square. Well, if I want to add half of whatever that is left over, I have this. And then if I add half of whatever's left over and add half of whatever's left over, add half, what ends up happening here? Well, I'm going to very, very tiny, end up filling in the whole thing. So having a pattern of a half of the previous thing, like 1/2, 1/4, 1/8, 1/16, and so on and so forth, I keep adding and adding and adding those smaller and smaller fractions, and that eventually I should be able to fill in this whole square of 1. So if I had a pattern of 1/2 plus 1/4 plus 1/8 plus 1/16 plus going on forever, it actually goes to 1. It actually starts adding up closer and closer to 1. So that's what this formula tells us, is that if I'm looking for the sum of an infinite geometric series, I'm going to take the first term and divide it by 1 minus r. And it's very important to know that the ratio has to be strictly less than 1, or the absolute value has to be strictly less than 1. Because if it doesn't, then it's going to be undefined. It means it has no sum. Like if I said I started off with 1, and let's just say I multiplied by 2. and multiply by 2 and multiply by 2 and multiply by 2 and keep on doing that, what happens? Well, you're just adding more and more numbers, so it ends up getting to infinity, which means that it has no sum. So that's kind of my explanation of it. So let's just know how to use the formula. How do I know that this is infinite? Well, it has an infinity sign in it. That's pretty easy. So this is an infinite series. If there was a number here like what we had previously, then it's finite. So you need to figure out how many terms there are. This is infinite. So I don't have a little subscript. The first term is plugging in the bottom number. So the first term is plugging in the bottom number into this formula. Now, don't always assume that it's 8. In this case, and in the last problem it was, but always plug in the bottom number. Because if this was 1, this would be a totally different problem. So, like I said, the first term for this is 8. You could keep plugging in numbers and realize that the ratio is 3/4. So, that's fine. Then all you have to do is do some math. 1 minus 3/4 is 1/4. 8 divided by 1/4 is not 2. You're actually multiplying by 4 and getting 32. So if you were to put this into the calculator and keep adding the numbers together, then you would end up getting closer and closer and closer to 32. Now, it might not ever get to 32, but we can say pretty well that it's going to get closer, 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 and closer to 32, that we can just say it's 32. Okay. All right. Number 11. Again, this is an infinite series, so I need to figure out the first term by plugging in the bottom number. So we get 8 times 1 again, which is 8. So again, without the little subscript, we should be able to say that this is infinite. Okay. The first term is 8 over 1 minus our ratio, which is different this time, is negative 3/4. So if you were to add 1 and negative 3/4, you get 7/4. And if you multiply the top and the bottom by 4, you end up getting 32/7, which again, leave your answers in fraction form. All right. Last question for the whole math stuff in high school. It's the last question. Should we just take our time for it or just get done with it? Yeah, I hear a lot of y'all are yelling. Let's just get done with it. All right. Now, the first term is 1/4. And if you plug in all of this information in there, you're actually going to get an answer. But what's happening here is I'm adding bigger and bigger numbers. My next term, my ratio here is 2. I'm multiplying by 2 each time. So I'm 4, 8, then 16, then 32. What happens if you just keep adding bigger and bigger and bigger numbers? Will you ever get somewhere? To infinity. But can you get to infinity? No. So what you needed to realize is that the ratio equals, or the ratio is bigger than 1. Ratio is bigger than 1. Well, if the ratio is bigger than 1, the sum is undefined, or what we usually like to say is that it has no sum. Okay. So again, what's very important to understand is that if the ratio of an infinite geometric series is bigger than 1, it has no sum because you keep adding bigger and bigger and bigger numbers. So that's PreCal Seniors for you, and thank you again for participating in all of the digital learning. I hope to see y'all soon. Bye.